This is 6.2a of geometry. So we're going to look at parallelograms. And as we go, I'm going to write out some bullet points that I think is a great way to take notes for this specific section. So a parallelogram is a quadrilateral, so it has four sides, with both pairs of opposite sides parallel. So that's the definition of parallelogram. So I would start your bullet point list labeling it parallelogram. So the first thing is that opposite sides are parallel, and that's just the definition of parallelogram. Okay, so like these guys are opposite sides, right? And these ones are opposite sides. Alrighty. So, Theorem 6.3 says that if it's a parallelogram, then opposite sides are congruent. So I would add to your bullet point list, opposite sides are congruent. That's pretty bad. And that's Theorem 6.3. Maybe we should make them dots. Okay. So consecutive angles are angles that share a side. So B and C are consecutive angles because they share the same side, BC. And C and D are consecutive angles because they share the side CD. And D and A are consecutive angles, and A and B are consecutive angles. And Theorem 6.4 tells us that consecutive angles add up to 180. So you can add that to your list. Okay, so we can use this. I'm going to draw out that parallelogram in there, or at least try. Q, R, S, and P. So they tell us that S is 86 degrees. Mark this parallelogram. So I can just use that last theorem that says that consecutive angles add to 180. So angle R, if I call it X, then I know that 86 plus X equals 180. And I'll subtract 86 from both sides. So I get that X is equal to 94. And this theorem shouldn't come as a surprise to you. If we look at this over here, here's my parallel lines. Here's R and S. Well, let's make that a little angled more to look like it. R and S. If you think back to when we were working with parallel lines, these are same side interior angles. And we know that same side interior angles add up to 180. It's the exact same thing we're saying with consecutive angles. Alrighty. Theorem 6.5 says that opposite angles are congruent. So the ones across from each other are opposite angles. Okay, we've got a proof now. So we'll draw our two columns and write in our given. It's pretty hard to mark that AK is congruent to KM. On this picture they already give me, so I'm going to draw a separate one where I just draw the big triangle. So this is M. A, and there's our K. So those are congruent. Now I'm trying to prove, let me switch colors for a second. I'm trying to prove that BCD, this angle, is congruent to this angle, CMD. I know that ABCD is a parallelogram. So then I would be allowed to say that this angle C is congruent to this angle A because opposite angles are congruent. So theorem 6.5. And then I could jump to proving that this guy here is congruent to this one down here. So that's my plan. Let me show you how we do that. So looking at this triangle, what kind of triangle is it? It's an isosceles triangle. And I know that if the legs are congruent, then the angles are congruent. So I can say that angle A is congruent to angle M by the isosceles triangle theorem. Okay, and I'll mark it on my picture as well. So then I'm allowed to say that angle A is congruent to angle BCD by theorem 6.5. That's what says that opposite angles are congruent inside of a parallelogram. And then now I'm allowed to say that angle M is congruent to angle BCD by either transitive or substitution. Remember transitive, if M is congruent to A and A is congruent to BCD, then M is congruent to BCD. And there you go, there's my proof. I just have a different name up here. That's also the same thing as CMD. There's your homework. I'm going to write out what your overall list should be. So, parallelogram. Okay, opposite sides are parallel. That's by the definition. Definition of a parallelogram. Opposite sides are congruent. And that was theorem 6.3. Consecutive angles add to 180. That was theorem 6.4. And finally, opposite angles are congruent. And that was theorem 6.5. There you go.